Yeah, so I'm just gonna. I can't work with different screens, so I'm going to share the same thing across both screens. So just bear with me while I do that. But anyway, so just a quick introduction. So my name is Paul Barnes. I'm a customer engineer at Google, which kind of means I'm a generalist across all of the Google Cloud platforms in a sales role. So hopefully this won't be too much of a sales pitch, but there may be a bit. But, do I apologise in advance for that? But anyway, so what I'm going to do is talk through a little bit about Kubernetes. Now, obviously, Docker, Kubernetes, they kind of seem more. I think at least at Google, we seem to have them hand in hand nowadays. So what I'm going to go through is kind of a reason why Kubernetes, some core concepts. I've actually got way more slides than I probably need to go through today, so I'll probably skip over a few things as we go, but do kind of stop me at some point if you want to know more about something that I'm talking about. Some general core concepts like architecture, cluster architecture, and some common patterns. But I'm also going to talk a little bit about how Kubernetes works on Google and kind of why we think the Google platform kind of works for you with Kubernetes and containers. And I almost come back to James's point earlier on, which is, does anybody run any of this in production? And my first point of that is, yeah, Google, everything we do is in production. So Google, I think we something like, this might be one of the slides, but about 1 billion containers a week that started and stopped at Google. So yeah, virtually everything Google does is in containers. So yeah, people are doing it at high volumes. So just a little bit of background, like history of computing. So, you know, the olden days where, well, I say olden days, for some people, the olden days where you had a server, you probably gave it a name. It was a bit of a pet machine. You put everything on it. You installed all of your software, everything that you did on it. But it became difficult, you know. You're either not running it. I think there were surveys out there that sort of suggest that people are running their servers probably at less than 40% efficiency. Probably people way more than that. And it's like, really, do you want to run your machine so inefficiently as that? So your next step is kind of like the virtual machine. So the same thing, same sort of technology, running the kernel, installing the kernel on every machine. You have the same issue with running dependencies. So can you run multiple versions? So I mean, anyone, a Python developer who uses virtual env now, why do you use it? Because of this same issue. You've got the problem with running dependencies. So how do you overcome that? And really, that's where containers. So people actually would go to the point of building a new virtual machine for everything. Every individual application had its own virtual machine. So the overhead that you've got in building this out and running this starts to become quite big. Now, if you've only got like 20, 30 servers in your business, then maybe this is something that you can handle. But when you start to get up to scale, when you get up to like hundreds or thousands or tens or hundreds of thousands, this is just not something that you can do. You can't keep scaling your business, your ops team at the same speed that you're scaling your hardware. So the next step, what do we do? Well, it's just this kind of like building of containers, abstracting the application, your application and the dependencies that go with this. So by doing this, first of all, you can put more machines or more application on a given machine, improve the kind of ability, like your agility and your efficiency of those applications, or the way that you use your hardware. So there's kind of the things that you need on a good distributed platform, like the 12 factors of coding as well. So all the sort of things that if you want to build a good distributed scalable platform, well, these are the kind of things that you start to need to think about. And this is where Kubernetes comes into it. So Kubernetes, so containers in their own, they don't really solve the problem of how do you run this sort of thing at scale, how do you make it, how can you scale your business without needing to scale your ops team. So that's where Kubernetes and the idea of automation and scripting things comes into this. So with Kubernetes kind of comes that your agility as a business. So basically, can you release code faster? Can you get more things out the door? I think that Google say that we push code changes into containers 25,000 times a day. So that's the kind of, how often you release applications at the moment? Month? Once, 6 months? Once a year?
High frequency. You've got to not be afraid.
So yeah, and that's kind of where we're getting to with Kubernetes and containers. It's the idea that continuous integration, continuous delivery. The minute somebody checks in code, something gets built, something gets pushed, it goes directly to maybe your canary release, or at least some kind of internal testing. So you can start making sure that your systems are working, things are independent, there's no real like tightly coupled dependencies between things. The other thing that you get with this is stability. So bizarrely, they always say that the time that your system will go down, probably 80% of those times are when you make a change. So by implementing something like Kubernetes and the flexibility that comes with, that means that if somebody's code change in one sort of like microservice or one part of the application, that doesn't stop everyone else's code from being released. But it means that it's stable as well, because the things that you've got that aren't changing, well, they're stable part of your application. So the ability to kind of roll back, just put a new sort of fix to something or change something quickly, gives you that kind of platform to build out on. And efficiency as well. So I think going back to that comment, so if you're running, people are running their servers at about 40% efficiency, then you're probably doing quite well. But with I can't talk and do this, sorry. So if you're running your servers up at sort of like 40% efficiency, you're probably doing quite well. 60%, you're probably doing really well. But by implementing something like Kubernetes, maybe you can get that up into the 80s. Maybe you can get that up into the 90s as well. So Kubernetes, built for Googlers basically. So Kubernetes is basically open sourcing what we do at Google. It's not quite that. I mean, effectively, we run a system internally called Borg. Kubernetes is basically what we do at Google, but removing all the technical debt that we have with Borg. So we've rewritten it to be in a kind of like a public open source application. It's now an official CNCF project, and so it's written in Go and organized by special interest groups. So all of the different areas it's something that if you want to be involved in, it's quite easy to just join up and start working on a specific part of the Kubernetes program or project. Kubernetes as well, often known as K8, and the reason why, just K and 8 characters. So what is Kubernetes? So basically it's a platform like a container orchestration platform. So basically it says here, so Google still deploys 2 billion containers a week on these kind of systems. And the idea is to take all of this kind of user applications that are running and basically packing them as tightly as you can onto your infrastructure. So it's declarative as well. So basically being able to say, this is what I want to do, this is what I want to achieve, and not saying this is how I want to achieve it. So basically saying, I want 3 servers or I want 3 copies of this running. Kubernetes goes away and does it for you without you having to think about how it does it. So again, and I think the phrase that kind of gets used there is that it kind of takes your servers away from being pets, where you name them all, to being like cattle. So basically you basically farm the same thing out to all of your machines. Every machine is effectively the same under the hood. You can run what you're running on any machine. You really don't have that sort of like tightly coupled application with your hardware. So the kind of the standard view is that you will have your developers, also your customers will be hitting your application. It's going to be managed, so all of your nodes, which is where your containers will actually be run, are managed by a single master. I mean, in a highly available, you can see it as a single master, obviously duplicated in a highly available environment. But effectively, the master is basically sending instructions to each of the nodes to say, do this, do that, start this, stop that, run this, run that. So the core concepts really are, the pod is kind of like the atomic unit of Kubernetes. So the pod generally runs one container. Sometimes you might see it as more than one container, but effectively the pod has the network interface, a container, and data, and sort of like storage volumes as well. The way you manage the pods is with a manifest file. So this is basically what a manifest file looks like. You send this and say, basically, I want my container. It needs to run my Nginx server. I'm going to open these ports. You send that manifest to the master. The master reads that, and it goes about. So it'll basically say, I want 3 of these, and it goes about sending those pods to the individual nodes. The nodes being the infrastructure, the individual VMs or hardware that you're running this on, and it'll basically choose where it wants to send that and try and pack those into those machines as tightly as possible. So the pod, so within a pod, I think as I kind of said, you've got your networking, you've got your data, you've got isolation with host names and C groups on there as well. You can install things, again, kind of going back to James's point, you could install things like a full LAMP stack on there and run a full LAMP stack within a container, or you could go down, breaking that down into microservices as well. There's no real limits to how you do this, and I think, again, going back to James's point, there are now papers and things on how to run stateless applications on Kubernetes as well. So there's plenty of papers that talk you through that kind of thing. So the deployment is about how you deliver those containers to those nodes. So a deployment, basically, an individual container on its own in Kubernetes is almost, I mean, it's not really something that you interact with. You're more likely to interact directly with a deployment. A deployment basically says, this is the end state that I'm looking for. I'm trying to get 4 copies of this. Go away, look at the infrastructure that I've got, and go and get me 4, and go and put start up 4 nodes on there. So basically, you can see here within your manifest file, you state that you want 4 replicas of this. The master goes away, sends a copy of those to each of those nodes. The next concept is the service. So the service is kind of what binds all of this together. So depending on, there are sort of 3 types of services. You'd have your external load balancer, your cluster kind of IP, and your, what they call it, nodes. What they call it now, is it? Node port. In order to like manage the communication between the applications or within the ports. So what most applications, so unless you're running lots of containers together, your infrastructure or your solution is going to look something like this, where you have the public load balancer hitting the service, which is understands or knows the IP addresses of all of the nodes that are running. Each individual container or each individual pod gets an IP address, so it's able to balance all of the load across each of those containers.
So it's a service within Kubernetes, and it's like bring your own load balancer.
It is basically, yeah. So you have so you can put a public load balancer in front of that, but effectively the service manages the load between each of the pods. So it kind of, I think you can set up the ways that you do it, but you kind of think of it as like a round robin against all of those pods to say where will the traffic go to. But the concept, I'm trying to think if I go on to this, the concept of this is knowing whether the master knows whether those pods are alive or not. So it knows where it can send its traffic. And part of that means that if the node, or sorry, if that pod fails, then the master will just start up another pod. It obviously communicates that to the service, and the service will start routing traffic to the new pod. So the idea of each of these pods being completely stateless means that it doesn't matter if that goes away. You've abstracted all of the issues that come with that by just having a stateless application that means that you can balance that load across all of those pods. Where you have multiple services, so multiple pods with different microservices in them, then again, your service layer is what ties that together. That's what allows those individual pods to talk to each other. So generally, in a slightly more complicated environment, this is what it might look like. So this might be kind of like your front web service, and this might be kind of like a middle tier in there as well. I just go backwards. So the namespaces is kind of logical isolation between each of your deployments. So the idea here is that you effectively have been able to define individual areas where you're going to run a specific application. So just to sort of like go a little bit into detail about sort of like the components of the masters and the nodes. So the master, obviously, scheduler, the API server, the node pool will run the container, but it obviously has this kube proxy and the kubelet in order to manage the communication back to the master. So the master knows the current state of all of the clusters, and it's the master that kind of is the thing that is talking to the individual nodes and saying, I want to run this, or we need to run that on a given node. So the master is controlling all of that. So as I said, that can be horizontally scalable for high availability environments. The API server is what makes the communications directly with each of the pods and with the nodes and the pods to say this is what I want to run in this given environment. So the server data store, this is where you again store things like your secrets, so anything like sort of passwords and things like that. So all of this gets stored within your ECD. The scheduler then, this is basically what does the work. This is the thing that takes away the operations that you would normally do when you're scaling up or scaling down your infrastructure. So the scheduler is the thing that is looking at all of your pods, trying to figure out what it needs to run, where it needs to run them, and it's going about trying to basically pack as many of those applications onto your nodes as you can. So the scheduler basically, I think I was kind of saying this before, but if a pod dies or if a node dies, then the scheduler kind of notices that something needs to change, and it'll instigate that by sending a request to the kube proxy in order to say, go away, run this application, or go and run this container or so for me. The same with if you're sort of using load balancers for this as well, you might choose to automatically scale up your application based on load. So when you hit a certain number of QPS or a certain number of load within your service, you will want to start up a new pod to manage the extra load. Obviously, if you're running on fixed infrastructure, then you can only fit so many pods on there as your infrastructure will manage. But that's where sort of like cloud service sort of come to your help. If you want to start up, you can run auto scaling within your cloud service. That'll mean that when you no longer have space to fit new pods within your infrastructure, you can go away and start up a new VM. You'd obviously try not to wait until you're at 100% to do that. So you'd be trying to maybe setting a state of maybe 50 or 60% across your machines before you start up your new service. Your new node. So just go over to so on your node you have the kubelet. This is what's communicating directly with the API server of the master. So obviously anything like your secrets will transfer through this as well. The container runtime, obviously this is where your application is running. So this is effectively what's being managed by Kubernetes. And the kube proxy, this is kind of watching the pods and services to make sure that everything's up and correct. Just jump over that one. So with Kubernetes, they have a dashboard. So as an open source project, actually, anyone who's familiar with using Google Cloud Platform, this looks pretty similar to the Google Cloud Platform interface. But there is a dashboard that comes with it as well that allows you to view and manage your applications. So I'm going to go over some of these bits fairly quickly. But so the kind of 4 pillars of Kubernetes being scheduling, load balancing and networking, resource management, and your environment management. So horizontal. So there's a few concepts that sort of like go with each of these. So the horizontal pod autoscaler. This kind of allows you to create new pods as and when you need it. So you're basically setting with here. As I said, this is all about declarative, saying what you want to happen, not how you want it to happen. So in this case, it's saying target average utilization of these will be about 65. You want minimum of 3 replicas running at all times, and you want a maximum of 9 replicas running at any given time. So this is where your master is looking at all of your pods, trying to work out the utilization and scheduling the, like bringing up new pods or scaling down pods as and when required. The cluster autoscaler. So this is something cloud infrastructure often takes care of this for you as well. But within Kubernetes, you can actually sort of like make those requests to cloud providers to scale up my clusters as well. I can kind of show you this in the Google Cloud Platform, but this is kind of saying I've got more. I need to run more pods than I actually have the infrastructure to run that at the moment. To go away, create me a new VM in order to run these new. Create me a new node or VM or node in order to run these pods. So the pod distribution budget, that's really about the limits kind of what you want to that read it up or down. So these are kind of like when you're making changes, you could say, so when you push a change to your code, you could say, for example, I want all of my nodes to be taken down instantly the minute I push a change, and then I want to bring up, so basically take down 10 nodes that are all running, bring up 10 brand new nodes. Now, that obviously isn't going to work very well for you if you want 100% uptime or like 99.9% uptime, because you're going to have a period of time where everything is down. Now, what it allows you to do is say, instead of if I've got 3 pods running, this can say, well, I always need to have at least 2. So when I'm pushing new code, I only take 1 down, and only once that is back up and running, that new pod is back up and running and working effectively, will you then take the next one down. So you kind of get this kind of concept of a rolling update when you're pushing new changes. So the load balancer, so you get both L7 and L4 ingress. So again, depending on the way that you set this up, you can define how you load balance against your applications. So the services, as I say, you've got the cluster IP, which basically manages the communication between the individual pods. So if you have multiple microservices within your application, then the cluster IP is effectively controlling that. The load balancer is really pushing the traffic, looking at all of the nodes, and sort of like deciding how to balance that new traffic that's coming in. And the node ports, the thing I've seen most with the node port is one of the kind of the common complaints you hear is that you can't see the external IP addresses of whoever's trying to hit your service. But by initiating node ports as a service, that allows you to pass through those IP addresses as well. So storage, again, a lot of this is really just showing you that it's all declarative on here. So basically I'm saying this is what I want for each of my individual pods. This is how I want to set it up. So logging as well. So Kubernetes kind of supports logging. Depending on, again, it depends on your infrastructure. It's kind of set up with Google in mind here, but we're using Stackdriver for that logging. But logging becomes, if you think about your 12-factor applications and logging just directly to your standard output, well, then you can start to use standard tools in order to manage your logging. So things like Stackdrivers or like Fluentd are able to pick those up and actually report those back to your log management system. Monitoring as well. So part of Kubernetes is Heapster, which actually runs within there and is actually able to sort of like configure out the monitoring from there. So the secrets. So again, if you think about the 12-factor, one of the things you see, especially if you start looking at things like GitHub, try and finding passwords. I think there's been some fairly high-profile things around that recently. But if you start putting your passwords and things into your code, or into sort of public, or sort of like public configs, then those things become very easy for people to identify. By maintaining these things in secrets, then you're able to keep those certain information private. But again, it just means that it's a config change. When you update something, it's a whole config change and not like a repush of a new application. So one thing that's a relatively new concept within Kubernetes is the idea of federated clusters as well. So effectively, every cluster that you have will have a master node, and even if that master node goes down, those individual nodes that are within, within that cluster will carry on working. It's then time, you're waiting for that master node to come back up in order to control them. But within that time, you'd obviously get no auto-scaling. You wouldn't be able to scale up or scale down your pod. But each of those pods should continue to work without the need of that master node. The idea of federated clusters is that helps you balance that across multiple environments. It may be that you've got, you're using, with Google Cloud, you're using multiple regions, multiple zones. It may be that you've got a hybrid cloud environment. This allows you to have a single master that's managing other masters within different environments. And this means that if you put a load balancer in front of this, you could manage your traffic across different zones, but your federated your federated clusters would effectively decide where the traffic goes, and if one cluster goes down, it would help bring up new environments or transfer traffic to an existing running environment. So to sort of like tie this all together in sort of Google, so Google obviously we open sourced Kubernetes, and we still have a very major sort of like influence within Kubernetes as well at the moment, although it seems to have become the de facto standard for orchestration of containers now. But Google are also building other tools around this as well. So Container Engine is our sort of managed version of Kubernetes. So Kubernetes, there's a lot of things that you still have to manage. If you're running Kubernetes on infrastructure, then obviously you have to manage the infrastructure as well. Container Engine basically takes that away from you. Container Builder and Container Registry and Code Repositories, these are all sort of like tools that you can use in order to support your CI/CD pipeline as well. So Google basically has a global network. You can see on here, all of this is kind of like Google's edge locations and Google's data centers. So we have over 100 points of presence around the globe. We also maintain our own networks as well. So we maintain our own fiber across the oceans. And what this means is that your communication, when you're running Kubernetes on Google, your customer will hit the Google network at their nearest edge node. That means that from that point, they are then uncontested on the Google network rather than on the public internet in order to sort of like transfer between countries to your servers. But this means that you get much greater sort of lower latency in your communications. It also helps if you're, for example, if you have failover environments around the globe. Again, that means that if somebody in Australia or someone in Singapore is accessing your application, if their application isn't running in their region, then it could just fail over. It would run on the Google network, and it would perhaps fail over to West Coast US or something like that. But that means that all of your traffic stays on the Google network to the closest point to that customer. So Container Engine is effectively managed Kubernetes. That means that Google becomes your SRE. So when your machines go down, Google is there trying to bring those back up for you. Google is monitoring the infrastructure. We actually do things like liveness checks. We detect sort of like crashed environments as well. One of the things that Google does is live migrates machine around as well. So we are able to update the underlying infrastructure. But what that means is that you don't have to worry about all of those patches to the core infrastructure that you're working on. And the idea of all of this is minimize downtime. And that's not to say that Google doesn't have downtime, and it's not to say that you won't be impacted by downtime. The idea is to bring something up to automate things in a way that is brought up as quickly as possible, rather than having to wait for the pager to go off and someone to identify the root cause and fix that. It's much more about fail over to an environment that is working and then resolve that kind of in the morning rather than at 2 a.m.
And reduce the number of outages based on manual change.
Yeah, so I mean, yeah, a lot of it, as I said before, it's when you're changing things that you have those problems. By running this, you're effectively not making it. So Google Cloud helps you scale basically effortlessly. Effectively, when you're setting up your cluster, you can say your minimum and maximum sizes. Your machines will then look at things like memory usage or number of connections or CPU usage, and you can basically say scale up or scale down based on the parameters of your environment. And this is really where the savings in cloud come in. If you're paying for your infrastructure 24/7, but you're only provisioning, if you're provisioning for something like the Grand National, or you're provisioning for your Christmas sales or Black Friday, then you're significantly over provisioning your infrastructure. If you can turn down those machines when you're not at that state, then you can save yourselves a lot of money. So a continuous delivery pipeline. So this is just kind of like an overview of the continuous delivery pipeline. But the idea here is that, so I mentioned these stuff. Your developers can check data directly into Google source repositories. The container builder application basically builds out your containers for you. So you can set up triggers that says every time new code is pushed into my source repository. This can also be something like GitHub as well. But you can read your every time someone checks in code. You can then store those containers in the Google Container Registry, and then use something like Spinnaker, which I'm not saying the de facto standard, but it's particularly the one that Google seems to be putting a bit of weight behind at the moment. But you can use something like Spinnaker to sort of manage your environment and push push new applications. So it becomes a fairly seamless thing. So if you think about what you go through at the moment in order to build your code and actually push it to live, well, this effectively automates that. So you could effectively commit your code and have that running within your application. I was going to say within 10 minutes, but probably much faster than that, but depending on the time it takes to build your application. So basically, thank you for your time. I hope you enjoyed that. But here's a few links if you want to learn more. So Google Cloud Next is where you'll probably hear a lot about the new things that Google are doing, particularly around Kubernetes and containers. There are there's a new course with Coursera that's just been released that really goes into Kubernetes engine. If you want something a bit more generic, there's a free course with Udacity that goes into building scalable microservices. But there are also a lot of code labs on Google as well. I was gonna go over this slightly, but there are these code labs that you can look at. They will walk you through the process. Almost sort of like James was mentioning about don't you do a demo, that kind of could go through something. But the idea here is that these code labs, in your own time, it walks you through how to set up your environment on Google and how to build out your application, scale up your services with Kubernetes, roll back. So if you go to codelab.google.com, there's kind of hundreds of new code labs in there that you can work through to sort of learn this technology. One final thing I was going to show you. is the comic guy, if any of you know who the comic guy is, but basically we have this why Kubernetes as a comic now. So if you'd like to go away and read that, give you a bit more background into Kubernetes. Okay.
I've got a question for you. So you talked about the continuous delivery pipeline there at the end. I actually run for our work, our own custom sort of homebrew CI/CD pipeline, and I'm actually running my own registry. It can be a bit of a pain in the neck to manage in terms of I need to keep SSL working, I need to keep my SSH managed and all that sort of stuff. So how painful is it going to be for me to actually migrate to something like the Google Cloud Platform? And have you heard of people sort of migrating that sort of thing?
I don't have any customer stories that I can talk about. Right. I don't know. I mean, if you want to sort of like investigate it, if you go through the code lab, like so this deploy a Java application. It says 36 minutes, so I'd say it's kind of 36 minutes of your. Okay, I'd say it's well spent to do this. So, but basically, it walks you through the process. So with every project that you set up on the Google Cloud environment, you get these repositories, which is effectively a managed version of Git. So you can push your code directly to that. Once you have those, you then would set up the container registry, which is where you can keep your images. You then set a build trigger on that,
right, okay.
And that build trigger basically runs all of that for you. So a lot of it depends on how far you want to go with things. Obviously, I mean, it's relatively easy to push your code directly up to Google source repository. I think if you're using something like Eclipse, there are Google tools with that will help you push your code. I think things like the container registry, it's there. You don't have to use it within Google, but I think you'll find it a lot easier if you do.
Yeah, because I run my own container registry on-premise hardware, and it works great to a point. So we have developers pushing code 2-3 times a day, and it does seamlessly build those images, ship it out to the registry, and deploy it to external staging servers. The problem is, it's all in my head. So to come to something like this, it's a standard level of kind of like, it's a familiar interface, it's Google, we use Google anyway, like in terms of the other things. So for uniformity, I think it might be a good idea. It's just interesting to see that Google offering that level of.
Yeah, I think, I mean, I was kind of having this conversation with Paul earlier on about a lot of these things, and I don't mean to sort of say SQL in containers is a good or a bad thing, but you sometimes wonder why you want to do things. And it's same with sort of like container registry. If you can find a hosted version of it, why would you do it yourself? You know, what's the benefit of doing it yourself?
I'm already asking myself that question quite substantially.
But it's you know, if that registry goes down, who goes and fixes that?
That man sat over there.
It's actually very relevant because we're running Ignite's file system, and our Ignite Turbo instances come off Google Container Registry, and they build automatically as we fire them up. And actually, for each new job, I can fire up a new Ignite Turbo, and that's now storage and everything. It's a container to run our storage for a job of advertising, and it's insane that once we started using Google, I'm into slipping completely into this, and your registry will be there shortly because it's usable. It's this man here wants to put SQL in containers for production, and there's no reason not to.
Well, the IT admin spoken now.
In my former role, we just used to build all our Docker containers on a build server in Google and then push them all to the Google Cloud Registry without any problem. And we used Travis, which would pull down those containers to do testing. We did try some other Google things, but we ended up going to Circle CI, for CI/CD. It just works.
Yeah.
You don't have to worry about it.
And it's kind of I don't know. It probably isn't at the moment, but I would hope it is getting to a commodity scale in the future. That there will be people that you can hire. Again, to kind of James's point, if you're struggling to find people for a particular technology or something, then if you're using like a generic version of that, you don't have to train someone up on your environment when you bring on someone new.
Because I've now started another job, but now I've gone over to AWS, and of course they've only just released their registry.
Yeah.
Because that was one of the things I was trying to search for.
Thank you.
Google Cloud Platform is something that anybody can sign up for
So-
and try something like you can do Microsoft Azure.
Yeah. So if you
free trial.
So
if you go on there,
there,
you get $300 that
Yeah,
lasts
for
12
a
months.
month.
So yeah, go on. I mean, the other thing that you can do when you set up these clusters, we have this concept of preemptible virtual machines, which are basically heavily discounted on a standard price. But the reason for that is that we might take them away. They will generally only last 24 hours, but we may choose to take them away if we need them. If